Hello and welcome to Best Practices for Performance Testing Mobile Applications. We'll be discussing some of the unique challenges and techniques associated with successful testing of mobile applications. First, before we get into it, I have an apology. Despite the title of this session, I don't believe in best practices. Best practices says to me, this is the only way to do something, and that's a pretty ridiculous statement if you think about it, especially given the diversity and complexity that we see in the systems we test every day. I want to be clear that what we'll be discussing are things that I've found to be successful in the work that I've done and ideas and approaches that I've learned in my communication with others. But please don't apply these approaches blindly to your work. Think about them, incorporate them into your existing body of knowledge, understand how they do or don't apply to your context, challenge them, and most importantly, contribute your thoughts and experiences to the community. So first, what are the key questions that we're going to answer in this session? Why is performance of mobile important? How is mobile different, and most importantly, how can I adapt? So why should you care about the performance of mobile systems? Well, looking at some statistics from mobile commerce, about 66% of shoppers abandon their transactions, and 50% of those abandoned transactions are due to poor performance. A 1-second delay equals a 7% drop in conversions, and that can translate for a high-volume retail site into millions of dollars. And this is all from a 2013 Mobile Commerce Insights study conducted by Jumio. In addition, the expectations of mobile users are essentially the same as those on traditional websites. They don't expect the response time or their experience to be any worse just because they're on their smartphone or their tablet. And your users have choices. They will abandon your site for a competitor if they don't believe that the performance is up to their standards. If you still don't think performance is important, it's a good chance someone in your organization does. According to last year's World Quality Report, performance is at the top of the list for mobile testing priorities. Before we dive in too deeply, let's take a quick walk down memory lane and think about the evolution of performance testing. This will give us a common understanding, at least at a high level, of where we are with performance testing today. So if we look back into the 1990s, performance testing was primarily performed on two-tier client-server systems. The challenges were we had proprietary protocols. Could we record and capture the communication? We certainly had a lack of skilled resources back then as well. If we looked at the state of performance testing at that time, most testing was performed in lab as essentially a science experiment. And as we got near the end of the 90s, we started to finally see some tool maturation and consolidation. As we moved into the 2000s, we started to see more complex, large, integrated systems, and systems that required testing at very large load levels as well. On the state of the practice side, we started to see the introduction of some open source tools and specialized resources, so resources who had the role of being a performance test engineer. Finally, as we moved into the next decade, we started to see the emergence of cloud-based testing to start to efficiently address those large load-level needs. But now that we've introduced mobile, where are we? What are those unique challenges? And most importantly, what can we do to address them? So first, let's look at some mobile challenges and adaptations. Your users have options when they access your systems, especially if you deploy a native app, mobile site, in addition to a full traditional desktop site. And your users will very likely have a different experience using the exact same functionality depending on how they access the system. Similarly, users accessing the system over different channels will have different effects on the system due to variances in the UI design, device performance, and network conditions. And we'll talk more about that in the next few minutes. So if our users have multiple options, we need to understand how they're accessing your system. So we need to assess the user and load profile. And getting the user and workload distribution right has always been a huge factor in getting value out of performance testing. These are essentially the inputs to your test. They, along with the test environment, will determine the value you get from the results. We could certainly have an entire presentation on determining the right user and load profile, so I'm not going to go into too much detail here. But I do want to focus on some of the criteria that are important from a mobile perspective. Traditionally, in the performance testing I've been involved in, hasn't included the factors that have extra importance for mobile. And the reasons for that are somewhat valid. The client time associated with total response time was assumed to be negligible. All users were accessing the same code base independent of their client configuration. And while users certainly access the systems over different network conditions, we typically said we weren't going to include what we couldn't control. And this didn't have a profound impact because most users were coming in over broadband networks. So while there were certainly variations, the low end of the spectrum wasn't anywhere near what the low end of mobile networks looks like today. In addition to including the important mobile factors, I want to highlight that your user and load profile should be in a constant feedback loop. Most organizations have the data via application logs and other analytic solutions to validate and adjust the test inputs over time. And this is especially important for mobile given the rate of change in mobile technology and the inherent diversity. The next challenge I want to discuss is the mobile network. The impact of network conditions on mobile app performance is great enough to warrant its own discussion. So many factors add to the variability of mobile network: Wi-Fi versus carrier network, type of mobile network, and of course the quality of the connection. The best 4G LTE network doesn't mean anything if you're in a tunnel. But why is this so important? Even a small percentage of mobile users can have a large impact on performance. Slower connection speeds, poor network quality will result in longer connection times that consume more server-side resources than their desktop counterparts. In extreme cases, an extra 10% of mobile users could exhaust all available connections, where if network conditions were ignored, you would never see that bottleneck under test. So we need to assess the impact of network variability. And it can have a huge impact on performance, but it's probably the most ignored aspect of performance testing mobile systems. A high percentage of mobile test plans and strategies that I've evaluated do not speak to network conditions at all. At a minimum, we need to look at baseline performance in a single user mode. Typically, that's done with real devices using some type of network virtualization solution. And network virtualization is fancy language for simulating the characteristics of a particular network. Typically, the solutions allow you to vary bandwidth, latency, and sometimes jitter. They also often come with popular presets that allow you to simulate different mobile networks, 3G, 4G, poor network connection, etc., and conditions that range to complete network loss. Ideally, we would also include network variability in a load situation. This is for both the virtual users and for measuring individual devices while the system's under load. What are some of our options in assessing the impact of network variability? There's a wide range of network virtualization solutions available. For single user, meaning assessing the impact of network conditions on the device or emulator specifically, we typically use Apple Network Link Conditioner for iOS and the Android emulator for Android apps. There's also an open source solution, Charles Proxy, which has some capabilities to vary network conditions. On the high end of the scale, in terms of both capability and cost, Shunra NV, which is now part of HP, offers significant capabilities. For running the primary load, in other words, the virtual users, through network virtualization, we find Shunra and Charles Proxy are both good choices. In addition, load test tools themselves have some capabilities built in. These might range from simple bandwidth throttling all the way to simulating latency, bandwidth, and jitter. The next challenge I want to discuss is user location and volume. A high volume of global users will be difficult to produce in a lab. In a lab, work small for maybe a few hundred to a few thousand sets of users. However, reproducing large volumes of users coming from diverse geographic populations to test, given most organizations' existing performance testing infrastructure. For tests where we have large volumes of concurrency, from thousands to hundreds of thousands, we typically use a cloud-based solution such as SOAS to Cloud Test. This allows us to very efficiently generate our required load, as well as exercise the same infrastructure that our users do. In addition, the cloud-based solutions also allow you to put the virtual users in various geographic locations around the world. In practice, we'll generate a large percentage of the load using cloud-based virtual users and observe the user experience on real devices while the system is under load. This can be done using in-lab devices, ideally with network virtualization, or mobile cloud devices from the various services. We prefer to use in-lab devices as we have more control over the devices as well as the costs. The next challenge we'll talk about is the performance of the device itself. As performance testers, we've gotten very used to measuring the system and network metrics while ignoring the user's client machine. And given that we essentially have unlimited, well, at least an abundance of resources on the workstations in terms of processing power, memory, power, etc., that's really not a terrible assumption, at least not for business systems. However, on mobile devices, we certainly have limits, and those limits can and will affect the performance of our apps. And of course, our apps can affect the performance of our device. If our app cuts battery life in half, the usefulness of our device, and therefore the apps, is certainly limited. At a minimum, we'll measure and track the app's usage of CPU, memory, battery drain, and storage. We like to include a number of target devices and configurations based on our mobile test strategy. And we'll typically incorporate automation for consistency. This allows us to highlight only the variables we're interested in versus trying to understand if the user's actions we're performing may have some variation in them that's affecting our results. I've included a list of solutions we've used to measure performance. Of course, you have the mobile development platforms themselves. From an automation perspective, we use touch tests from SOSTA, Trust from Mobile Labs, or Monkey Talk from CloudMonkey. All these solutions have the ability to capture device metrics while an automated test is running. We maintain a mobile device lab that contains the most popular devices required across our projects. Specifically, we use Device Connect from Mobile Labs. For situations where we need to test on a device that we don't have in our lab, we might use one of the available mobile cloud solutions. The next challenge I want to talk about is Agile Development. And historically, performance testing has been done at the end of a long waterfall development cycle, very strict, very rigid, very scientific-like test. And with the move to Agile, very short sprints, performance testing has gotten lost to some respects. So we really need to understand how performance testing fits. First, let's look at performance testing in a waterfall environment. Typically, it has very strict entry criteria. Functional system testing must be completed, code must be froze during the performance testing effort, execution in a production-like environment, and for those very reasons, it's performed late in the SDLC. And typically, it's a one-way, throw-it-over-the-wall communication of results from the performance testing team. So even given all the accolades that performance testing of this type has received over the years, the information that was provided was too late, just like turning your head before the freight train hits you. If you find issues, your options are all less than ideal. Delay the release or defer resolving the issues to a later release. So now if we look at an Agile environment, and one way I've seen organizations try to address this is to perform the same type of performance testing at the end of a handful of sprints. And the reality is it's the same process. We're still finding out way too late that we might have performance issues. And I think we could agree that performance issues, if they're found, are much more likely to have major design or architectural impact than other functional type issues that might be found. So there's definitely benefit to understanding performance issues early in the cycle, and that's what we'll start to discuss next. So one way to try to get performance issues surfaced earlier in the development cycle is to take that same rigid performance testing approach and try to apply it to the end of each sprint or possibly every other sprint. But the problem is the entry criteria, the strict entry criteria, typically the longer cycle, maybe 4 to 6 weeks to do a performance test, does not fit in the approach, and the results can be disastrous. So we need to find another way. And the way to do that is really to look at the ultimate goal. We want to shift away from late cycle performance testing to early cycle and really ongoing performance analysis. And I use analysis intentionally because it's really more than just performance testing. So how do we do that? Well, the first step is to look at unit and component level performance testing instead of large end of cycle system level performance testing. And some of the techniques we've used to successfully incorporate unit and component-based performance testing is, first of all, to map the business and end-user requirements onto the system components so you understand what units and what components are being executed, and then we can design tests that focus only on those specific components. Because very often early in the cycle we don't have a production-like environment, we're benchmarking these tests in a development or QA environment. Because of that, we really can't make absolute decisions on response time and other user-level metrics. So instead of looking at absolutes, we look for trends in those measurements from build to build. Similarly, because we're early in the cycle, many services or other components have yet to be developed, so we make heavy use of service virtualization to stub out those yet to be developed components. And finally, as we evolve, we'll look to execute those unit performance tests as part of continuous integration, so we get immediate feedback as part of the build process if we have affected performance negatively. Another technique is to use application and code profiling methodologies. We'll look at the resource performance profile of native apps on the device itself. And for mobile sites, we'll use online services and tools to analyze the performance of individual pages and services. We'll also use APM solutions to profile the code early in the development cycle. Similarly, there are device profiling solutions available that allow you just to compare the base performance of different devices to predict how your application might perform across devices from the client perspective. So for those of you that have been part of a large performance testing center of excellence that has traditionally performed the end of cycle system level performance tests, you might be asking, well, how do I fit, or how does my COE fit in the Agile model? So I put together a slide that at a high level shows various aspects of a COE, both in a waterfall and Agile. In a waterfall methodology, typically the COE is performing a turnkey performance test. They're getting the system at the end of the cycle, they're executing a test, and then throwing the results over the wall. Duration is typically weeks, maybe 4 to 6 weeks, using traditional load test tools. The environment that's being executed in is dedicated and production-like typically. And again, the role of development here is to give the system over to the COE and then wait for those results to come back. In an Agile environment, the performance testing COE is more of a mentor to the Agile teams to help them understand how to shift the performance analysis left in the cycle. What makes up a good test? What types of things are we looking for? And this is an ongoing process. Performance becomes everyone's job. The duration of these activities might be hours or at the most days, but they certainly fit within the context of a sprint. Still using traditional load test tools, but also APM tools. Service virtualization is important for the unit and component level testing, as well as continuous integration as the teams start to evolve and mature with performance analysis. The environment that we're executing in might be a development QA environment. It might even be a developer's desktop. So again, we're looking for trends and measurements and not absolutes. And the development now has a constant focus on performance versus a throw it over the wall at the end of the cycle and hope for the best. To summarize the key takeaways of this presentation, it's important to remember that mobile users are not the same as connected users. We need to understand the fact that they're on mobile devices, and that inherently impacts the performance of the system. Also, performance is much more than just the back-end network performance. We do not have unlimited resources on our mobile devices, and that is going to impact our applications as well, and we need to understand what that is. And finally, we need to start pushing performance analysis to the left in the development cycle. Finding out at the end of a development cycle, just before it's released to the user community, that we have performance issues obviously is not the ideal time. We need to shift from an end-of-cycle performance test to ongoing performance analysis. So thank you again for listening to this presentation, and you can see the contact information. If you have any additional questions, please feel free to contact me through any of these mediums if you have any additional questions. Thank you.